Systems are two equations working together. And the reason we have such systems of equations is because sometimes you need more than one equation to find your solution. And in systems of equations, you're going to have more than one variable. The ones we're going to work with, you're going to have two variables. How many ways can you solve a system? Lots of ways. You can solve systems graphically. You can solve them using a table. You can solve them algebraically. What we're going to do is we're going to solve them algebraically today and tomorrow, and then we'll go on to the graphic representation of them. So, you can have many ways to solve systems, and systems are just two equations working together. So when you hear that expression, systems of equations, don't let it confuse you. It's two equations working together. That's it. The first way to algebraically solve a system of equations. It's not hard. It's substitution. You guys have done that before many times. It's a little bit time consuming because there are a few steps, but it's very simple. So what you want to do very first is you want to solve for one of your variables. It doesn't matter which one. And it doesn't matter which equation you take it from. You've got two equations, two variables, x and y. Choose whichever equation you want, choose whichever variable you want, and solve for it. I'm going to make it as easy as possible, so I'm going to take the equation 2x plus y equals 10, and I'm going to solve for y. So y equals 10 minus 2x. Now, if you guys were told y is 7, you could substitute 7 in for y. Well, y is 10 minus 2x. So you substitute 10 minus 2x in for y. You take the other equation, whichever equation you didn't use, and in this case, we didn't use the 3x plus 4y equals 12. So I'm going to plug y in there. 3x plus 4 times 10 minus 2x equals 12. And solve. This isn't going to work out perfectly. You're going to end up with a decimal or a fraction. That's okay. I don't care if you make it a decimal or a fraction. I really don't even mind if you use a calculator to do this. You're going to get that x is 5.6. Or 5 3/3 if you made a decimal form. Just throw it on there. Thank you. But how many variables do we have? 2. X and y. X and y. Right now all we have is x. So we have to find y. So your third step in a system of equation is to go back plug that variable in to find the other. What's nice is you can plug that x back into any equation. You can plug it into this one, or you can plug it right into this one, where we have y equals 10 minus 2x. So I'm going to have y equals 10 minus 2 times 5.6. Plug your x value in. Y equals 10 minus 11.2. So y equals negative 1.2. Sure.
Couldn't you just do it like without making the y go out front?
How so?
Like I just plugged in x and then I got 1,000. Oh wait, never mind. I think I typed it in.
Yeah, I think that's probably what happened. Now you can also write your answers as an ordered pair. 5.6, negative 1.2. That is your answer to the system of equations. You with us, Chen? If you wanted to, you could check these. You could take your x and your y value and plug them back in. For your first equation, if you plug them back in, you'll get 12 equals 12. For your second equation, if you plug those back in, you'll get 10 equals 10. It takes a while to go through that whole process, but it is a good way to double check if you're doing your homework or if you're doing a test and you want to make sure that you're correct, just plug them back in. On your homework, I think it tells you to check your solutions, but you don't need to do that unless you want to. I'm not going to require it unless you want to. For the next one, it's the same idea. What's the solution to the system of equations? So we've got two equations. Your first step is to solve for one of the variables. I'm going to solve for x because it's already by itself without a coefficient. So x equals 5 minus 3y. Choose the easiest variable to solve for. Once you do that, you need to go and you need to plug it into the other equation. So I'm going to take this equation that starts with negative 2x. Instead of x, I'm substituting 5 minus 3y. And then solve. Two y equals 5. So y equals 2.5. That's part of your answer. But remember, we have an x and a y value, so we need to find both. Plug that back into one of your equations. I'm going to use x equals 5 minus 3 times y is 2.5. And you get that x is negative 2.5. So your solution here is negative 2.5, 2.5. Systems of equations are one of the best things to apply to real-world situations because a lot of the times you are dealing with more than one variable in a situation. The problem is talking about piano lessons. And it says that this music store offers piano lessons for a discounted price for customers who are buying a new piano. The cost for lessons and a one-time material fee are shown in this advertisement. What's the cost of each lesson and the one-time fee for materials? Now, this is very applicable to advertisement because maybe it's not a very good deal if you don't realize the math behind an advertisement. If you can't figure out, well, hey, what's the one-time fee? What's the material fee? Maybe this isn't a better deal than piano place B down the road. Okay? Sometimes you have to use math to figure out what's the better deal. Actually, all the time. You need to use math, you need to use logic to find out what the better deal is. And we can do it by systems of equations. Sure, you could do it by a guess and check method, but this is much more efficient. So, we have for 6 lessons, $300. For 12 lessons, $480. We want to find out how much a lesson costs and how much the one-time fee for material is. How much does one lesson cost? How much is the material fee? You guys try to come up with 2 different equations. Okay, so we have the cost of one lesson and our material fee. Those are our 2 variables. Try to come up with your 2 equations. So we know if there are 6 lessons plus the one-time material fee, we have to pay $300. 6, we have to pay $300. 6 lessons, so 6 times the cost per lesson, plus whatever the material fee is going to equal $300 that we would owe. And then for 12 lessons, it would be 12 times the cost of each lesson, plus the material fee is $480. Now you can solve the system. I'm going to just choose one variable to solve for. It's pretty easy to tell it should be f. What I'm going to do is use my first equation. Does not matter if you picked your second equation. You can pick either equation. F equals 300 minus 6c. Then once you solve for one variable, plug it back into the other equation. So now I'm taking my other equation that I have not used yet, and I have 12c plus f. So that is 300 minus 6c equals 480. C minus 6c is 6c plus 300 equals 480. Subtract 300 from both sides. 6c equals 180. So how much does each lesson cost here? Jordan? $3. Right. And we also need to find out what the one-time fee is for material. So I'm going to plug 30 in. F equals 300 minus 6 times 30. And you get that there's a 120 one-time material fee.